Welcome to another edition of the InfoQ podcast. My name is Wesley Reisz, one of the co-hosts of the show, and also one of the chairs for the QCon Software Conference, which will be returning to London April 4th through 6th. Check out QConLondon.com for more information. Today on the podcast, we're speaking with Stefan Prodan about Flux and Flagger and the operator pattern applied to non-clustered resources. As many of you may know, operators are a software extension to Kubernetes that make use of custom resources, CRDs, to manage application components. You might use it to package, deploy, manage a database, or Kafka, Confluent has a Confluent operator on top of a cluster. The operator pattern applied to non-clustered resources is that idea, leveraging that pattern to extend beyond the cluster to manage K8s and non-K8 resources alike. Flux CD is a GitOps toolkit for continuous delivery that Stefan Prodan, the principal engineer at WeWorks and core maintainer of, uses in the project. And we'll discuss that today on the podcast. Today, we're speaking with Stefan about the latest on Flux CD and Flagger, a complementary progressive delivery framework, and also the notion of building on top of the K8s API and what benefits and challenges and things that it'll give you. We'll start the podcast off about reviewing Flux and Flagger in the DevOps toolkit, and we'll get an update on the project, and we'll hear the philosophy of Flux CD. And then we'll look at maybe some things about how Flux does some things that are a little different than other progressive delivery frameworks. We'll wrap with a discussion of the operator pattern applied to non-clustered resources. As always, thank you for joining us on your walks, jogs, and commutes. Stefan, welcome to the podcast.
Great to be here. I'm very happy to talk about the latest and greatest in Flux CD.
For people who may not be familiar with Flux, before we jump into the latest and greatest, what is the elevator pitch? You're on the elevator, you're telling another technologist what Flux CD is all about. Level set us. What's Flux CD all about?
Flux tries to bring apart the CI/CD landscape, right? We are used to mixing all together in our CI pipeline where we build the software, we test the software, then we deploy the software. Right. Flux is trying to take the continuous delivery part from outside the cluster to inside the cluster. So instead of having some tool that connects to the cluster and from there it performs the actual delivery process, with Flux, it's a shift in paradigm, right? It's the cluster that looks at a Git repository or some form that describes the desired state and tries to reach to that desired state. So it's very different from what we had before with CI/CD.
That's that pull versus push discussion that you see a bit with CD platforms. So push is like reaching into the cluster to say, this is what I wanted to do, where pull is actually pulling things in. Why is that such an important distinction between push versus pull?
One thing is, how do you detect drift from what you actually run to what you want to run? If you do that from outside, you'll have to, let's say, every 5 minutes, connect to the cluster. Is my cluster in the right shape or not? Oh, it's not. Let's correct it. Right. So it's not just a one-off. And CI for me and for many of us is just one-off. If something happens in your Git repo, you change your source code, that gets built and that's the end of it, right? While continuous delivery and your production cluster is a live system where things change all the time and you want to detect any kind of drift. Let's say someone made some changes which are unattended or whatever, some other tool made some changes and those changes may get the production system into a bad shape, right? How do you correct that mistake automatically? From CI it means, you bombard your cluster all the time with all sorts of opening connections, verifying and all that stuff. It's like running Terraform in a loop, which doesn't quite work.
So I have a couple questions about the project. I hear Flux and Flux CD used almost interchangeably. So one question is the project name Flux or Flux CD? And the second question is around V1 and V2. V1 I know is in maintenance mode and it's GA. V2 I know has a bunch of new features still being released, but it's not quite GA yet. Do I have that right?
There is no such thing as Flux CD. Flux CD is the organization on GitHub. The project is called Flux and it has 2 versions. Version 1 is GA for a very long time. Right after WeWorks donated Flux to CNCF, half a year after that, we've launched Flux V1 GA. For 2 years now, we are working on version 2, and we have a roadmap for when version 2 will go GA.
What are some of the big architectural differences between V1 and V2? I know, for example, V2 had multi-tenancy and supported multiple Git repos. What are some of the others?
Flux version 1 was built as a monolithic tool where it could reconcile your whole cluster from a single Git repository. And that was it. You deploy one Flux instance, and at deploy time, you configure how it should clone which SSH key and so on. And from that moment on, all it does is reconciles that repo on your cluster. In Flux version 2, the main difference is that we split all these functions of Flux version 1 into dedicated controllers. And this is how we build a GitOps toolkit. So we have like a source controller that deals with all types of sources where you define your desired state, like Git repos, Helm repos, and so on. Then we have these specialized reconcilers. For Helm is called Helm controller. For customized overlays and plain YAMLs is called customized controller. If we want to configure alerting or webhooks, then we have notification controller. And we have other types of controllers for driving automation. For example, we have a built-in automation where we listen for events on your container image registry. Let's say you push a new version of your app as a container. Flux is able to listen to that event, match the new tag that is pushed against a policy that you can define. Let's say I want only stable releases to land on my production cluster and I want those patch versions to be automatically deployed. Flux can do that for you. It will detect a new version in your container registry. It will patch the manifests back in your Git repo. Then the other components of the GitOps toolkit will take that modification and will apply it on the cluster. And Flux is a distribution of all these controllers combined. Now, for example, VMware Tanzu only uses some of those. And you can pick and choose, and that's the major change from Flux 1 to Flux 2. If you don't want to buy into the whole thing and you only want to deal with, I don't know, you want to use sources, but instead of reconciling stuff inside Kubernetes, maybe you want to do a Terraform build and apply, right? And you can do that. There are examples out there. There are controllers out there that only are using some components of the GitOps toolkit to build their own continuous delivery systems.
Got it, right. So the GitOps toolkit is the foundation everything's built on. There's also Flagger, which is a progressive delivery tool. How does that Flagger relate into the suite of tools?
Flux is the one that, you make a change in your Git repo. Let's say you have a new app version. Flux bumps the container image tag. Let's say from version 1, it goes to version 1.1. And it will automatically upgrade your application inside your production system, right? But maybe you want to do this in a progressive manner. Maybe you don't want all your users to be impacted by the new version. Maybe there is a hidden bug in there. Maybe there is a performance issue and so on. And here is where Flagger comes into place. What Flagger does is, instead of letting Flux roll the new version to all your users, it uses service mesh technologies or ingress controllers like Nginx, Contour, and so on to slowly route traffic from the old version to the new version. And while it increases that traffic weight from one version to another, it can look at metrics like Prometheus metric, Datadog metrics, and so on to determine if the new version breaks any kind of SLOs that you have set for those. Is there a route? Maybe the latency is too high, your users are having issues, and so on. When it detects a problem, it will automatically roll back. What that means is shift the traffic back to the old version, scale the new version to 0, and alert your dev team, hey, something is wrong. These SLOs have not passed. All the checks that I've run, do another deployment. So what will happen, like the dev team, let's say, finds the issue, pushes a new version of that source code, that gets yet again tested, validated by Flagger, and in the end, it ends up in production, and all traffic goes to that new version. But the thing is at the end of the continuous delivery pipeline where you want better control over what's actually exposed to your end user.
What do you get out of it? Does it give you the red metrics to be able to just watch your latency, errors, things like that? What do you get out of the box when you want to leverage Flagger as far as the analytics?
Flagger uses the red metrics by default. That's because most service meshes and ingress controllers are already instrumented with Prometheus, right? So when you configure a canary deployment with Flagger, by default, it can do two things. Look at the error rate, being HTTP errors or gRPC errors, and it can also look at latency. So you can set some thresholds for latency and error rate. Other things that you can do with Flagger, you can tell Flagger to run tests, smoke tests, before it exposes the new version to any user. So before it routes 1% of your total users to the new version, it can run some smoke tests for you. It can run Helm tests for you and so on, right? So here you can extend it. There are a lot of Flagger users which have extended Flagger. Flagger calls out to some webhooks, and it's up to you there in that implementation to determine which tests are you running and so on. After those tests have finished, you report back the result to Flagger, and that's how Flagger advances and takes decisions and so on. And also with metrics, we have this custom resource, which is called, yet again, in Kubernetes, a custom resource, another API, which is called metric template. And you can use custom metrics if you have those, if your application reports these kind of metrics, and you can define other checks based on those metrics. And it's not only about Prometheus, you can reach to Datadog, Stackdriver, and other offerings that expose all sorts of metrics.
So you mentioned the road to GA. What's the latest with the project? What are some of the big things that you've been focused on of late?
At the end of last year, CNCF sponsored Flux with a security audit, which was made by EDA Logics and was facilitated by OSTIF, which is the Open Source Technology Improvement Fund. And that was kind of revealing for the Flux project. We are on a road to release Flux version 2 GA, and having this security audit gave us confidence in the direction where we are going, and it came up with great findings around what part of the code we should improve, how we should write our documentation better, and how we should approach security in Flux from a different perspective than what we did before. As a result of that audit, we now have an RFC process in place for any kind of security changes. We made a lot of security improvements on our side. Now we have, for example, fuzzing for the Flux source code. We sign our container images when we push them to our users. We also publish a software bill of materials with each release. So we are trying to hardening that part where people actually trust and can verify the instance of Flux that is running on their cluster is the same as what we are delivering. So that's on one side. And on the other side, we made a lot of improvements when dealing with security inside the cluster. You may be aware of, but there are lots of organizations that are running different teams collaborate on a single cluster, right? And those teams, you can think about those teams as tenants. So these types of organization need some kind of isolation between tenants, and we want to offer that with Flux, basically isolating the tenant's desired state from each other. So a tenant could not change some other tenant deployment, could not affect the whole cluster state, could not introduce a new policy or stuff like that.
Let's talk about specifically that security audit just a bit, and also, I guess, the CNCF process of becoming an incubating project and becoming a graduated project. For those who maybe don't know, if you look at the landscape and you see those large boxes out there, that means they're actually a CNCF project. And these things like the security audit that you just mentioned are things that you have to go through to become a graduated project. Can you talk a little bit for a minute about, just so people that maybe aren't familiar with it, what things you have to go through, like that security audit, to become an incubating and then a graduated project?
Well, I think graduation means different things to different people. But to me, it means once our code is as secure as we can possibly make it. And in order to determine that, we can't do our own audit, right? You have that option. You can audit yourself. I know other projects were doing that, but we felt like if we can get a sponsorship here and get a dedicated team that is used to this kind of analysis and give us a real feeling about how we are evolving Flux. So that's on one side, of course, security. And on the other side is also about adoption, right? You cannot be a graduated project if you are in a very niche zone with just a couple of users. So Flux has seen major adoption in the last couple of years, adoption from end users, but also adoption from other vendors. There are cloud vendors like Microsoft, for example, which is shipping Flux in Microsoft Arc, or Amazon, which is shipping Flux in their EKSD offering, and so on.
Or as you mentioned before, VMware Tanzu as well. We use some of the Flux controllers as part of mission control and the Tanzu application platform.
Yes, and we are looking forward to new partnerships with other cloud vendors and solidify Flux on this market as the continuous delivery tool to go.
A lot of times when we talk about continuous delivery and Flux comes up, people really quickly will also mention like Argo CD. So I'm curious, when a developer architect is considering two different tools such as Argo CD and Flux CD, what are some of the philosophical differences between the two?
Flux offers a vast API in terms of how you configure it. We have, especially Flux version 2, extends Kubernetes with custom resources. Argo CD offers this custom resource, which is called the application, but we thought that application is not the right concept when you build a continuous delivery pipeline. We are dealing with so many things, from trusted sources, which Git repository do you trust, or Helm repositories do you trust? What things you are deploying? Maybe you are deploying, I don't know, cluster add-ons, which don't quite fit into the app pattern, databases, applications, or maybe some type of configuration which affects things outside the cluster, right? So the main difference between Flux and Argo from the API point of view is that we have this rich API where you define things like sources, which can be Git repositories, S3 buckets if you want to store your desired state there, Helm repositories, and we are looking at adding now OCI as a source type. And once you define these sources, then you can create other custom resources which are referring those. And there you configure how your secrets are decrypted, how you apply those resources on the cluster, how you do health checking of those resources. And here we have two specialized controllers, and this links back to the GitOps Toolkit idea, where we have controllers dedicated for a specific action. For example, you may want to apply on your cluster a customized overlay, right? So we have a thing called customized controller, which understands customize, and it will look at sources which define these customized overlays and apply those on the cluster. Or you may have Helm charts, and maybe you're deploying the apps, you package apps with Helm charts and you deploy them with Helm releases. Well, Flux has a Helm release custom resource, and you define that in your Git repo, and that's how that application gets reconciled. And at the end of this pipeline, we have another controller called notification controller, which captures events from all the things that Flux does on your cluster. And then with custom resource called alert, you can filter those events and funnel those events to external systems like Slack, Microsoft Teams, writing back to GitHub, for example, and add the commit status. Is it green or is it red? What did actually fail, right? And because Flux doesn't have a user interface, we rely more on people using the Git SaaS user interfaces like GitHub, GitLab, and so on, and our CLI. So all our tooling is made towards react to events, take some decisions, and emit events that report what decision we took and what happened after those, and write back to the systems that people expect to, a Slack channel, in your Git status, and so on.
Okay, got it. So event-based system, reactive system that operates with cluster and non-cluster resources. Very nice. So let's switch over and talk a little bit about this operator patterns applied to non-clustered resources. So when you built Flux v2, it's built on top of Kubernetes. It uses kind of the Kubernetes API as like the foundation to extend and build the Flux API. Why go that route? What benefit is there to a developer building an API on top of the Kubernetes API using the Kubernetes constructs?
In the last 2 years, Kubernetes made a lot of improvements around extending it. There is a controller runtime project, which you can think of it like an SDK. So you have a collection of libraries, and you can use those libraries to build a controller from scratch. It also has code gen features and so on. So it's really nice. And on top of, there is also Kube Builder project, which has a nice CLI for bootstrapping your whole project. So back when we started working on Flux 1, 5, 6 years ago, there were no such tools. So we had to build everything from scratch. And in version 2, we've seen these tools and we automatically wanted to use them and adopt them because it makes development so much easy for Kubernetes. And another big advantage is that in a way, your controller is developed in the same way and behaves in the same way as a native Kubernetes controller, one that comes with Kubernetes itself, right? And the main advantage of extending Kubernetes API instead of building your own and having an HTTP endpoint inside the cluster is that you can rely on Kubernetes RBAC and Kubernetes authentication and security when people access your API. That's why Flux can be used for multi-tenancy even if you run a single instance of Flux on your cluster, because each custom resource depending on which namespace it's deployed, is subject to a different Kubernetes RBAC, and you can limit what users can do with Flux on the cluster without coming with another layer of RBAC and access control on top. What Argo CD, for example, is doing. They have their own RBAC and so on. We rely only on Kubernetes RBAC. So adopting Flux from that perspective should be super easy, because you can create service accounts for each tenant repo. And then you say, oh, when you reconcile this particular repository, all the applications in here, use this service account, use this identity. So no matter what the developer will place in that repo, let's say a cluster role binding or something that's, at cluster level and could impact everything, even if that person does that, Flux will not be able to apply that change on the cluster, because it is limited by Kubernetes RBAC and what the cluster admin decided that a particular repo should contain or not, or how it should affect the cluster state or not.
Now, what about extending beyond the cluster? So those are the benefits of actually on the cluster itself. How do you, extend some of that, like security model, for example, when you're talking about non-clustered resources? How do you deal with that? How do you think about that? What are some of your considerations?
So part of our GitOps toolkit, we have built a series of libraries and best practices on how to extend Flux with a new controller. So if you use controller runtime together with our library, it's quite easy to extend Flux to other things than what Flux does. Flux by default is in charge of dealing with Kubernetes objects and the Kubernetes cluster state. But using our libraries, you can extend Flux beyond Kubernetes. For example, Weaveworks is currently developing a controller called TF Controller, which is a Terraform extension for Flux. What that means is that you place your Terraform definitions in a Git repo. You use the source controller as before to, connect to the Git repo, maybe using authentication, maybe ensuring that whoever committed changes into that repo is actually an authorized person, let's say using OpenPGP and commit signing. Flux has no idea about what to do with Terraform. It only knows Kubernetes YAMLs and Kubernetes objects. But this Terraform controller, built on the same platform as Flux, reacts to events. Oh, there is a new change in the Git repo. Let me take that Terraform change, create a plan for it, apply it outside Kubernetes to whatever it needs to do, maybe create time roles, create S3 buckets, or whatever it has to do, and then report back what changes, how they were made inside the cluster. And from there, you can use Flux Notification Controller to funnel out those events back to the end users. And there are many other technologies right now which try to get to use Kubernetes as an API for driving changes outside Kubernetes itself. And there are Pulumi, there are so many things there. In order to make all of this work with Flux, is either you expose a custom resource, and that custom resource tells Flux how to change those things, what type of tool it should use to reconcile stuff, or you build your own controller and you extend Flux in that way.
So earlier you talked about the road to GA for Flux v2. When do you think v2 will be ready for GA?
We are getting close there. The security audit was a major milestone. The fact that we got all these eyes inside the project and we have an RFC process and so on. We got major adoption from cloud vendors and end users. We are getting closer to GA. What we still want to do is get more feedback on our current APIs. So our current APIs are at V1, Beta 1, and Beta 2. That means people that are currently using version 2 in production, even if we release tomorrow GA, those APIs will suffer no breaking changes. And even if there will be breaking changes, we'll offer an automatically conversion for version 1 Beta 2 to version 1 final, or whatever the API versioning is. So for me, GA is more about having awesome docs on all topics that Flux can do, and we are still working on that, and have better observability for everything that Flux does. And what we are working right now, what's our top priority is around observability. We offer all kinds of things, like we offer Prometheus metrics for everything that we do. And now what we are trying to do is have better eventing system. Emit events only once and with the right information. Now we are emitting way too much events. So we need to trim those down and make them as clear as possible for users. And besides the observability part, we are also doing a work where we are now consolidating our source code. Being so many controllers, they share a bunch of code, but as with development, we don't build libraries first. We build the actual projects and then we consolidate the source code into libraries. And that's the last mile of what we are trying to do. Consolidate the code, adding better observability to it. And write development documentation. We have a lot of people asking us, hey, how can I extend Flux? And we say, hey, go to this project and look at the source code. Well, that's not the best approach, right? So we are working right now in having documentation for development, not only for end users. We have vast documentation for end users and almost none for developers. And I think that shows maturity when you have that. And we really want to get at that point before going GA.
Well, Stefan, Flux is an awesome tool. Thank you for taking the time to chat with us and talk a bit about it.
Thank you very much for inviting me. It was really fun.